name is Erin. I work with the North Dakota Space Grant. Today I'm going to be walking you through an activity called Water on Mars. I'm going to go through the classroom procedure as well as some modification you can make for remote or at-home learning. We call this activity Water on Mars because it simulates if you went to a different planet and you needed to find water for your space mission. But what is water? How do you define it? How will astronauts be able to not only locate it but know that this is for sure water and we can use it for the purposes for drinking or farming, and even rocket fuel requires water. To start off, you're going to need a couple of things. You're going to want a variety of different clear liquids. You want all of your liquids to be clear but with different consistencies and properties so that as students conduct tests on the samples, they can determine which one is water. Today I'm going to be using paper cups to hold my samples. You can also get some clear film canisters or prescription bottle type things where you can see through it and see the sample from all angles without picking up and moving around the sample too much. For my demonstration, I've used hand sanitizer, vinegar, a clear soda, plain water, a makeup remover. This particular one has two different kind of substances in it. One of them is obviously a little bit more dense and less dense, so it kind of layers when it's just in there. This isn't necessary, it's just another type of consistency you can use. Corn syrup is another thing that's a lot thicker, that's good for a different consistency. For that kind of makeup remover, you want to make sure to shake it so that you get both types of fluids kind of equally distributed within your sample. And witch hazel. These particular liquids aren't required. You can add in or substitute different liquids depending on what you have available to you and in your classroom. One of the big ground rules is that students cannot taste any of the liquids. It's a surefire way that we know if water is water, right? But we can't just go out to Mars and taste some random liquid we come across. We gotta make sure that it's safe and is water before we consume it. So that you have each of your samples, you're gonna wanna make sure they're numbered so you can identify which substance is which so that students can correctly match them on their worksheets or observations, referring to it by its number instead of its name. Prior to conducting the tests, they won't know what substance is which. So next, students are gonna wanna go through a series of tests conducting on each of the samples to try and figure out which ones they know aren't water and which ones they think might still be water. But a modification you can make for at-home or remote learning is that as the instructor, you can act as the rover, right? Currently, we've never sent people to Mars. All of our science is conducted by rovers that scientists here on Earth have to use remote sensing techniques to determine the properties of different rocks and hopefully someday water. So you can have students decide what tests they want their rover to conduct, and a teacher asking if the rover can then conduct these tests, whether over a video call or however you're currently structuring your virtual classes. For the purpose of a demonstration, I like to write the actual name of what the substance is on the back just so I can easily look at it without having to refer to what number something is and just some of the tests. I kind of want to know what it is I'm putting in it. Upon looking at the liquids, students might immediately zone in on the carbonated water or clear soda and notice that it looks different, right? It has a bunch of bubbles. So they might be tempted to just toss it out and say, oh, that's not water, because water doesn't bubble like that. But does it? Does water bubble naturally on Earth? It does. And how do we know that the sample we're looking at right now isn't bubbling naturally or isn't bubbling? Another thing students will probably do pretty much right after getting the samples is smell their samples. It's quite fragrant to have all of these different vinegars and sodas, waters, and different liquids. This is something that doing it remotely students won't be able to do, and is pretty similar to how scientists study things now. We can't smell Mars. We can detect certain things in the air, but we can't physically smell it like a sample, so that can just be another remote sensing type technique. In person, you can ask students not to smell the liquids right away or keep them in those closed canisters to start where they can't smell them. In a virtual environment at this point, you may want to ask students what tests would we conduct? Like what kind of things can we use to determine which one of these liquids is water? And what makes water? To start, students should make a list of characteristics they deem make water water. These can include things: how does it look? How does it smell? How does it feel? What's its viscosity? Does it evaporate? The different things dissolve in it, and what makes the water so distinguishable as water. So some of the things you can test with are salt, table pepper, baking soda, cornstarch, and sugar. Another thing that you'll want to have on you is some parchment or wax paper or even tin foil. Just a little sheet is okay. You're also going to want to have some sort of tool to touch the liquids without actually physically touching them. I'm just using a regular kitchen knife. You can use popsicle stick or tongue depressor, kind of little wooden things. So there isn't one specific correct order for the tests to be done. You can kind of work with students, ask them what tests do you think we should do first, What's the kind of important things, or what kind of tests do you think will rule out the most substances? For time's sake, I'm not going to go through every single test on every single sample, but I will kind of show how some of them are done. A viscosity test, which is basically how runny or how thick a fluid is, can be done by just taking a little bit of the sample and kind of rubbing it onto something. You can kind of see, does it well up into a little ball like the hand sanitizer I just used? Kind of, it doesn't completely flatten out. Different substances interact differently with the wax paper. How can students determine which one is something characteristic of water? Along with this, students can also use that little smear on a table and kind of maybe mark which fluid is which and just leave it for a while. If a substance completely evaporates in a couple of minutes, what does that mean? Or what does it mean if it's still there? Is it something characteristic of water, or does that mean it's probably not water? One of the obviously pretty interesting tests students are going to want to do is just take a small amount of baking soda and with the vinegar, it'll fizz up and make noise. And with other substances, nothing happens. So right away you can see one thing that might be an issue with students contaminating samples. So you want to give them that initial container full of the sample, as well as multiple smaller cups so they can kind of divide the sample into, so that they don't conduct one test on a sample, for example, put baking soda in vinegar and then try to do another test after that to try and remove as much air as possible. So as students conduct these tests, they can definitively say, yes, this is water, and no, this is not. For example, after putting baking soda in the vinegar, they can probably say not water, and they can set it aside and mark that on their sheet. If they aren't quite sure on something, they can also keep it and conduct further tests on it. A substance like salt is something that we know dissolves in water. So if it interacts with other substances, is it also going to dissolve? For example, in this makeup remover, the salt kind of immediately clumped all together and went to the side. Black pepper is something students can use kind of to test how thick liquid is by the way it interacts with pepper. For example, when I put the pepper in the hand sanitizer, it just sticks. And with the water and other liquids that are a little bit more runny, it kind of spreads out and moves a little bit initially. Another one that may throw some of the younger students off if they aren't familiar with this experiment is cornstarch. For some of them, it doesn't really do anything. It kind of just clumps up, doesn't even really dissolve. But for others, such as water, right, it kind of clouds up initially. If they don't add quite enough, it won't really do too much. It'll kind of just cloud up. But if they go ahead and add more, upon adding cornstarch to water, it'll kind of form this really cool non-Newtonian fluid, which is when you kind of push it between your fingers or apply pressure to it, it acts kind of hard, but will run as a fluid when you don't do that, or if it moves slowly. Sugar is another example of something you can use. pH strips, if you have them available to you, can also be used to determine the acidity of a substance. For fluids like that makeup remover that kind of separate into two different densities, you can try having students put other objects in them other than just pepper flakes, to see like where does it stop. Like when you make the density bottles where you'll layer like milk, oil, water, and then drop different objects in and you can see what their density is, you can kind of do the same thing and show them the different densities. It's a property that would be able to tell them it's probably not water. This is a good activity to collaborate with the students and make a new process and activity with them so they can kind of work through the different scientific process and how they would determine if something is or is not water. It's also going to teach them about physical characteristics, both intrinsic and extrinsic. You can have them find density of an object with mass and volume. I think any activity with little baking soda volcanoes and oobleck always makes me really excited. They're also really practical to create in a classroom setting and easy to apply to this kind of concept. Thank you so much for watching. I've linked information about this activity below. Please check out our website to see more different activities we have available for educators for both at home and in classroom applications. Just have a great beginning, middle, or end of a semester or school year, whatever you're watching this. Thank you so much for watching.